Assalamualaikum and good morning, everyone. Okay, so for today, we are going to look at a new topic on root locus. So there will be two lectures on root locus. So in today's lecture, I'm going to introduce to you on what is root locus. Okay. So after completing this lecture, you will be able to understand the problem with control system that requires root locus and then determine the properties of root locus. Okay, so what is root locus? So root locus is a graphical representation or graphical presentation of the closed loop poles as the system gain parameter k is varied. So let's say if you are given this kind of system, a closed loop system, so you have a forward transfer function gs and a gain k. So you have a gain k here, and then you have a feedback. So a feedback has a transfer function hs. So maybe you can try to obtain the closed loop transfer function. So from here, the closed loop transfer function will be k times g over 1 plus kg-ish. So here we have the gain k here. So the gain k can be any number. So you need to, so in real life, you will tune the control system. You will tune the gain k to obtain a stable control system or a control system that follows your requirements. So here, when you vary the gain k, then every time you vary the gain k, then you will get a different value of poles when you solve for the denominator later. So the gain k here will be always changeable. Okay? So you can change the value of k, and when you change the value of k, then the system stability will also change. So this is an example of what I'm trying to explain just now. So let's say if you have this system, so forward transfer function is k over s times s plus 2, and you have a unity feedback. So when you change the value of k, you will see from this figure here, the time response is also changed, and the stability of the system actually depends on the value of k here. So for example, if you use k 0.5, then the system is, I think, overdamp. So for overdamp system, it will reach steady state value, but it will take a longer time to reach the steady state value. So you can change this k value. Let's say if you change to 15, k equals 15, then you will see that this system becomes under dam. I think it's under dam. So under dam, then you will see there's a overshoot here, and then it will have some kind of vibration before it reach the steady state value. So I think you have when you do your project part 2 on second order system, you will you already seen a system that has overshoot, that has a steady state value or steady state error. And when you do quiz, I think quiz number 2 also, you have seen different kinds of second order system like overdam, critically dam, underdam, and so on. So all of that actually depends on this value of k. So when you change the value of k, you will get a different types of system behavior. So let's look at the control system problem that requiring root locus. So let's say again you have this system that has forward transfer function kgs and a feedback transfer function hs. So if you derive the closed loop transfer function by simplifying the block diagram, you will get this TS equals KGS divided by 1 plus KGS times HS. So from here, let's say each of the GS and HS has its own numerator and denominator. So NG here is numerator for G, DG here is denominator for G, and same for NH and DH. So you can try to expand this. When you expand, you will end up with this final transfer function or final equation here. So from this final equation, you can try to find the poles from this closed loop transfer function. So if you look at the denominator, then in the denominator, there is a term from DG, from DH. There's a K here, NG and NH. So the denominator consists of numerator and denominator of forward and feedback transfer function. And then the poles, if you look at denominator, the poles now depends on the gain K. So here there is a K value here. So when you change the value of K, then you get different solution for denominator. So therefore, with closed loop system, the poles are not easily obtained and the poles will change with the value of K. So we need a graphical representation. So this graphical representation meaning that when we change the value of K, then we plot the new value of poles. So new K value, we get new poles value and so on. So let's look at an example. So let's say you are given GS S plus 1 divided by S times S plus 2 and HS equals S plus 3 over S plus 4. So you can try to obtain the closed loop system. And then from the denominator, you can try to find the poles. So to find the poles, you must make sure that the denominator equals 0. And then from here, you can try to deduce what is the value of S for the denominator to become 0. So it can maybe 0, minus 2, maybe minus 4, or even minus 1K or minus 3K. So what are the poles? What are the value of poles actually for this equation? So it's indeterminate. You cannot determine this. So here the poles we have to factor the denominator, and now the denominator depends on K. So you cannot find the poles unless you know the value of K. So what happens if you change the value of K, then the poles also change in value. So that's why we need to use root locus technique in order to find poles. Okay, so that's the problems with control system that requires root locus. Okay, so before we go into detail about root locus, so let me introduce to you the basic of complex number. So we know that the value of S can be plotted on S plane, like the poles and zeros can be plotted on S plane, and this value of S actually can be in complex number. So maybe we have real parts and imaginary parts times j. So j is square root minus 1. So s, the value of s, can be in the form of complex number, real number, plus imaginary number times j. J is square root minus 1. So let's say you have this complex number. So if you still remember what you have learned about complex number, maybe in your first year maths, maybe in calculus. So complex number can be equivalent to a vector. So when we plot the complex number on S plane, so we have the x-axis. We plot the x-axis as the real part and the y-axis as the imaginary part. So let's say if you plot the complex number with this blue vector here. So here we have the angle of this vector. We call it as argument. And we have the magnitude of this vector, or we term it as m, magnitude m, and argument theta. Argument is the angle. So similar to vector, so complex number also has magnitude and direction. So to determine m, you just find the square root of sigma squared plus omega squared. And to determine theta, basically you need to determine the angle um, based on how you look the angle, okay? So in this case, theta is measured here. So it's simply tangent minus 1 omega over sigma. So let's say if you have a complex number, maybe located here. So theta is measured from positive x-axis. Measured from positive x-axis. So to find this theta, what I will do is I will measure this angle, let's say alpha. So I will find it as 90 plus alpha equals theta. Okay, sometimes you can use cosine, sometimes you can use sine, but all of that depends on how you measure the angle theta. Okay, later on we will see more example on this. So therefore, we can also represent the complex number using only magnitude and direction. So we write like this. So S equals M. So the triangle here means the angle. Okay. So M, magnitude M, angle theta. Okay, so let's say if we have a transfer function f, so fs equals the product. So this symbol here, this big pi symbol, meaning the product of s plus 0 divided by the product of s plus poles. So maybe similar to what we have learned last week. So maybe if you have f equals s plus 1, s plus 2, for example, divided by s plus 3, s plus 4. So the numerator is the product of s plus zeros divided by the product of s plus poles. Okay. So to find the magnitude and angle of this complex number, you can simply find the magnitude. So to find the magnitude, you just calculate the product of the length of the zero divided by the product of the length of the poles, or the product of the vector of the numerator divided by the product of the vector of the poles. And then to find the angle, simply find the sum of angle for the zeros minus the angle of the poles, sum of angle of poles. Later on, we will see an example. So this is the formula. So to find the magnitude, you just multiply all length of zero divided by multiplication of all length of poles. For the angle, you sum all of the zero angle minus the sum of all angles. Okay, so this is an example. So let's say you are given fs equals s plus 1 over s times s plus 2. And then you are given a point s equals minus 3 plus J4. So you want to determine at this point on this transfer function, what will be the magnitude and direction. So at this point, minus 3 plus J4, what will be the magnitude and direction on this transfer function? So firstly, you substitute this point into the transfer function. So now S becomes minus 3 plus 4J. So you substitute every S with minus 3 plus 4J. So you get this. And then from here, you need to determine the magnitude and angle for each of the complex number. So for example, the top one here, the numerator minus 2 plus 4J. So for example, minus 2 plus 4J. So you determine the magnitude. So magnitude 1, square root minus 2 squared plus 4 squared. So you get square root 20. And then the angle. So if you want to plot it first on S plane, so minus 2, maybe here, and then 4J here. So the vector is somewhere here. So the angle is measured here, theta 1. So to find theta 1, from my my way of measurement will be I can do 180 minus this angle. So that angle will be 4/2. So tangent minus 1, 4/2. So we can try calculate. Okay, so this is the angle and this is the magnitude for the first numerator here. And then you calculate similarly the magnitude for this and angle, and also magnitude for this and also the angle. And then what you do is to find the magnitude, the overall magnitude, you just find the product of magnitude of the 0 divided by product of magnitude of poles. So this is overall magnitude. And then the angle, you find the sum of angle of 0 minus the sum of angle of poles. Okay, so that's why there's a minus here. Okay, so I showed to you the measurement or the calculation for the first complex number here. Maybe later on you can try to calculate the second complex number and the third complex number and try to validate with the answer given in the slide. Okay, so if you stuck, please let me know, then I can help you. Okay. Okay, so each of this magnitude and angle represent this each of these blue lines on the S plane. Okay. Okay, so that's the basic about complex number. Any question about complex number that you still unsure, or maybe you need something, some insights?
Clear, yeah.
Okay, so please try, and if you stuck, please let me know. Okay.
Yeah.
Okay. Now let's look at the main topic of this lecture, which is the root locus. So after we understand about the complex number, now we can look uh, on what is root locus. So let's say if you are given a system. So here in this example, we have a camera motion detector, maybe motion detector camera. So this is usually put on the ceiling. So let's say you want to measure the movement of something or movement of a person. So let's say a person is moving, then this camera will capture the motion of the person. So usually when the person is moving, we will put something on the body of the person to indicate the motion of each joint on the body. So the camera will detect this joint and then maybe measure the position of the joint. Okay. So the control system for this camera can consist of an amplifier. So amplifier basically try to strengthen the signals measured from the camera. So usually the amplifier will have a gain. So here in this case, it has gain K1. And then the camera also has a motor that that rotates the camera, and then the camera itself. So maybe in this example, the motor and camera has a transfer function K2 over S times S plus 10. And then the system is in a unity feedback. So this is a unity feedback system. So firstly, we simplify the block diagram. So we can simplify it, and then we get this closed loop transfer function. So here, the example simplifies K. So K equals K1 times K2. Okay, so to make things easy, so the transformation is represented by one K only, which is K equals K1 times K2. And then from this K, from this transfer function, we can change the value of K. So maybe we can change from 0 until 50. And then for example, if we give value 0, then we can try to find the poles. So if K is 0, then the poles becomes minus 10 and 0. Okay, so when K is 0, so you get S squared plus 10S. So this is denominator. So to find the poles, basically simply make this equation equal 0. So you get S equals 0 and minus 10. Okay, so that's why you get minus 10 and 0 when K equals 0. And then you can change the value of K. So in this example, it changes the K from 0 to 5 and then calculate for the poles. And then repeat the process for K equals 10, 15, and so on, and determine the poles. So you have this table, value of K and value of poles. And then we can try plot all of these poles on S-plane. So here, when K equals 0, the poles at minus 10 and 0. So you plot all of these poles on S-plane. So you'll see something here like a shape. Then we can connect all of these points. So when we connect all of these points, then we get this red cross here, a red cross graph. Okay. So this graph that we just plotted is known as the root locus. Okay. So this graph here represent the path of closed loop poles as you vary the gain. So when you change the value of K, then the poles also change. So that's why this graph here has a arrow direction, because it changes from k equals 0 to k equals 50. So one part of the graph maybe start from here and then move downwards. Then the other part starts from 0 and then can move upwards. Okay. So when you change the value of k, then the poles also change. That created this graph. Okay. So what can we learn from this graph? So from k from 0 to 25. So for this within this range here, the system is overdamped. So you can prove this by using MATLAB. Okay, so when you use MATLAB, you can plot the time response, and you see that from k equals 0 to 25, the system will be overdamped. So when k equals 25, or at this point here, then the system is critically damped. And lastly, when k bigger than 25, or at this point onwards, then the system is underdamped. So when you change the value of k, then the system behavior also change. Okay, so that's what we learn from this. Okay, when we change the value of k, then the system will also change. Okay, the behavior, because the behavior depends on the poles. So when you change the k value, it changes the value of poles and directly affecting the behavior of the system. Okay, so overall the system is stable. So because there is no poles on right hand side, okay, no poles located on right hand side. So all of the poles are located on left hand side. So that's why the system is stable. Okay, so any questions so far?
None of them.
Okay, so now let's look at one of the properties of root locus. So let's say you want to determine whether a point is located on the root locus or not. So let's say you are given this unity feedback system with forward transfer function. So please take note here. So it's a unity feedback system, but the GS is this. Okay, so this is the GS for unity feedback system. So the unity feedback system has HS equals 1. Okay, so always remember, for unity feedback system, HS equals 1. Okay, so for this unity feedback system, is this point minus 3 plus 0j is on the root locus. And then if this point on the root locus, determine the value of k from this point. Okay, so there are steps on determining this. So firstly, you determine the zeros and poles of this forward transfer function. And then you determine the angles from zeros and poles, from this zero and poles to this point of interest, which is minus 3. And then you determine the length of the vector from zeros and poles from this transfer function to this point. And then at all angles, if the angles are multiple of 180, then the point is on the root locus. Then determine the k using length of 0 and poles. Okay, so let's look at this one by one. Okay, so step 1. So determine the zeros and poles from the forward transfer function. Then you can plot on S-plane and also plot the point of interest. So this is the GS. Okay, so you can find the poles and zeros. So here the zeros will be minus 2. So you can plot circle at minus 2. And then the poles is at minus plus 2 plus minus 3j. Okay, so this is the poles. So you can plot this on S-plane as well. I think this is plus kot, salah kot. Okay. So this should be minus. Okay. So you plot this on S-plane. So the cross here represent the poles. And then this point here is the point of interest, minus 3. And then step 2, you determine the angle from all of these poles and 0 to the point of interest. Okay, so the first angle is measured from this cross to this point. So you always measure the angle from positive x-axis. Okay, so you measure from here to this point. Okay, so this angle. So to measure that angle, you to find the angle is depends on how you calculate. Okay, so this example dia guna 270 minus tangent. So it can be many ways. Okay, maybe 180 plus tangent, for example. So all of that depends on how you calculate the angle. Okay, but you will end up the same value. And then the second angle, theta 2, is measured from positive x-axis to this point. So theta 2 here is simply 180 degree. And lastly, theta 3 measured from positive x-axis to this point or to this line here. Okay, so you get all of this angle. Then you can add all of the angles. If when you add the angle, it equals the multiple of 180, then that point is on the root locus. Okay, so to add the angle, you must make sure that you identify this angle is measured from poles or from 0. So if it is measured from poles, like theta 1 is from pole and theta 3, you need to minus them. So theta 2 is from 0. So remember the formula. So the angle will be summation of angle from 0 minus summation of angle from poles. So that's why you get theta 2 minus theta 1 plus theta 3, because theta 1 is okay, so it's a multiple of 180 degree. Then the point is on the root locus. Then when you know the point is on the root locus, then you can determine the gain k. So to determine the gain k, firstly you need to determine the length of vector. So again, look at the S-plane that you plotted. So you need to determine this L1, the length L2, and length L3. So again, this is trigonometry. So you can use theorem Pythagoras, okay? Theorem Pythagoras to calculate L1, L2, and L3. And then to determine the gain K, so this is the formula. So K equals 1 over magnitude of G times H, or simply 1 over the overall magnitude. So using the formula that I've shown earlier, so the overall magnitude equals the product of 0 length divided by the product of pole length. Okay, so we know that L1 is from pole and also L3 and L2 from 0. So here the numerator will be 1 L2. So M equals L2 divided by L1 times L3. So you get M equals 1 over 10. Then K will be 1 over M. So K equals 10. Okay. Okay, so that's it. Any question before we try the tutorial question? Dia macam complicated sikit. But it revolves around calculating the angle and also the magnitude. Okay, so maybe later on you can try to calculate again the angle and magnitude, and then verify your calculation with the example given in the slide. Okay. So as long as you understand how to measure the angle and how to measure the length, then you will be fine. Okay. Tak ada masalah.
Okay, Doktor.
Okay, so let's look at tutorial. Okay, jap. Okay, so let's look at the tutorial question. Okay, so tutorial. So tutorial 10 is about covering this topic lecture 4C. So a unity feedback system with a forward transfer function GS equals 1 over S plus 2 times S plus 4. So determine whether the points S minus 1, S minus 3.5, and S minus 3 plus 5G are on the root locus or not. Then for those points that are on the root locus, determine the gain K at that point. Okay, so first step, so maybe we can write the transfer function first. And then we have point minus 1, minus 3.5, and minus 3 plus 5J. Okay, so firstly, you determine the poles and zeros of this transfer function. So the poles are S equals minus 2 and minus 4. And then this transfer function has no zero, okay? Because the numerator cannot become zero. Tak boleh jadi kosong. So there is no zeros. So you have these poles only. So maybe you can then plot this on S-plane. So we have minus 2 here and minus 4. Then to see clearly the location of the 3 points here, you can plot them on the S-plane. So for example, minus 1 will be located here. Minus 3.5 somewhere here. Minus 3 plus 5J will be somewhere here. So from here, we know already that this point -1 is not on the root locus. Okay, so we will learn more about this next week. But point -1 will be not on the root locus, will not be on the root locus. But this point, -3.5 and -3 will be on the root locus. But let's calculate, okay? So let's prove by calculation. So we start by s-1. So maybe we can redraw the s-plane. So firstly, you need to determine the angles. Okay. So second, you need to determine the angles. So maybe you want to determine this angle, theta 1, and then this angle, theta 2. Okay, so theta 1, if measured from, measured from this pole to the point. So measured from this pole, -2, to point -1. So this angle measured from here, so it's basically 0. Okay, theta 1 equals 0. So theta 1 equals 0. So similar to point -4. So theta 2 also 0. So then you can find the sum of angle. So sum of angle from 0 minus sum of angle from poles. So there is no angle from 0. So you have minus angle from poles only. So 0 plus 0. So you get 0. So 0 is also multiple of 180, but it's basically multiply 180 with 0. So this is tak boleh terima, okay, not acceptable. So you will accept if it is 180 times something times n. So n not equal 0. So here the angle is 0. The sum of angle is 0. So the point -1 is not on the root locus. Okay. Now let's try for the second point, which is -3.5. So again, let's redraw the S-plane. Then firstly, we need to find the angles. So angles. So angle from -2 here is measured from here to here, theta 1. And from -4 is measured here. So theta 1, obviously 180 degree, while theta 2 is 0. And then you calculate the sum of angle. So you get 0 and minus 180 plus 0. So you get negative 180. So it's a multiple of 180. Hence the point 3.5 minus 3.5 is on root locus. Okay, so this point is on the root locus. Then now we can determine the gain k. Okay. So to determine the gain k, first we need to determine the length. Okay, so determine the length here and the length here. So let's say this is L1 and L2. L1 is basically 1.5. Okay, panjang dia or the distance. And then L2, the distance is 0.5. Okay, so I think this is the problem that I encountered last semester. Tapi dah lupa kenapa. Okay. So K equals 1 over M. So M equals the product of length 0 divided by product of length poles. Okay, so we don't have the length 0. We only have the length from poles. So I think from last semester, after we discuss, I think we can equal this to 1. Okay, 1 divided by product of LP. Tapi lupa kenapa satu. Okay, I forgot why it's equals 1. So product of LP, so it's simply L1 times L2. 1 over L1 times L2. So you get 4 over 3. So substitute into this. So K equals 1 over M. So equals 3 over 4, 0.75. Okay, so this is the gain K at this point. So this point is on the root locus. So only when the point is on the root locus, then it has the gain K. So for example, in question number 1, because point -1 is not on the root locus, so there is no gain K for this point on this root locus. Okay, so only points that located on the root locus will have the gain K. Okay. Okay, so last example, last question. So -3 plus 5j. So we can plot on S-plane. So firstly, we need to find the angles. Okay, so you need to calculate this angle and this angle. Okay, so the angle is always measured from positive x-axis. Okay, please remember that. So theta 1. So the way I calculate theta 1 will be 180 minus this angle. So this angle, let's say alpha, is tangent minus 1, 5 over 1. Okay, this length. Okay. So you get 101.3. And then theta 2 will be tangent minus 1, 5 over 1. Okay, so this length and this height. Okay, so you get 78.7. And then determine the sum. So minus theta 1 plus theta 2. So you get 180 degree minus. So from here, we know that this point is on root locus. Okay, this point on the root locus. And then because this point on the root locus, then we can calculate the gain K. So again, you need to calculate this length, L1 and L2. So try to find length. So L1 will be using theorem Pythagoras. So it will be square root 5 squared plus 1. Okay, square root 26. And then L2 will be square root similar 5 squared plus 1. So square root 26. And then using the formula, so K equals 1 over M. And then M equals a product of length from 0 over product of length from poles. So because there is no 0, it's equals 1 divided by L1 times L2. So you get 1 over 26. So substitute into here. So you get K equals 26. Okay, so this is the gain on that point, minus 3 plus 5J. Okay, so that's it for this tutorial. Any question?
Understand.
Saya still tak faham kenapa yang pertama tu angle dia kosong.
Yang mana? Oh, yang nombor 1 Okay, kita tengok kat sini. Okay, minus 2 kat sini. Belah kiri minus 1. So kita measure angle dia dari positif x axis. So minus 1 ni terletak di belah kanan dia. So kita nak measure angle ni dari positif x axis. So bila dia letak sini, sudut dia kosong lah. Faham tak? Let's say minus 2 and then 1, minus 1. So katakan minus 1 kat belakang. So we measured the angle from positive x axis. Okay. So kalau dia terletak kat belakang dia, then the angle will be 180. Tapi sekarang ni minus 1 ni terletak di hadapan dia. So kalau dia terletak kat sana, angle dia kosong. Faham?
Okay, baru nampak.
Alright. Okay.
So doktor.
Yes.
So yang angle tu kenapa kosong juga?
Yang mana? Minus 4?
Ya
sorry,
tu.
Sorry.
Yang
minus 4 pun
ni.
Sama juga macam ni juga. So minus 4 sini. So 1 dekat sini. So minus 1 dekat belah kanan dia, on his right, dekat belah kanan. So angle dia kosong lah sebab dia measure macam ni. Dia measure ke arah kanan, arah positive x axis. So let's say if minus 1 is di belakang, then the angle will be measured from positive x axis. Will be 180 lah. Tapi now minus 1 is in the front, okay? Dekat depan. So kat depan dia 0. Sama macam minus 2 tadi, konsep dia.
Okay, boleh.
Okay?
Okay.
Alright. Okay, so try to understand how to measure the angle, to calculate the angle, try to calculate the length, because from lecture 4D nanti, there will be a lot of calculation involving calculating the angle, calculating the length. and you might get confused. Macam pening, alah kenapa ni, macam jadi pening kepala. And then in topic number 5, lecture number 5 later also will involve calculation of length, angle again. So try to understand how to calculate the angle and length, and also understand that the sum of angle is basically sum of angle from 0 minus angle from poles, and then the product of length, the magnitude, is product of length zeros divided by product of length poles. Okay, we will use this a lot later. Okay, so if you have no question, then see you on next Wednesday. Okay, Monday cuti. Okay, thank you very much. Assalamualaikum and goodbye.
Okay, thank you, Doctor.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Thank you.
Good.
Thank you very much.